So friends, now we are discussing the types of function. Function are basically four types. One function, the type 2 is many one function, the type 3 is onto function, and type 4 is into function. Okay, so please write down the statement. Types of function. Types of function. So function are how many types? Four types. So please write. Functions are four types. Okay, these are what? One, many one, onto and into. So these are number one function, number two many one function, number three onto function, and number four is into function. Number 4 is into function. So into function. Okay. One functions are also known as injective function, and onto functions is known as bisective function. Okay. So please write down. One functions are also known as injective function. Injective function. Okay. And onto functions are known as bisective function. So write down bisective function. Is it clear? So many one functions are non-injective and into functions are non-bisective functions. Is it? So what we learned, functions are basically four types. Number one is one function, number two is many one functions, number three is onto functions, and number four is into functions. One functions are also known as injective functions, and onto functions are also known as bisective function. Okay, so now we'll discuss step by step, that is which type of functions are known as one function, which type of functions are known as many one functions, and so on. Okay, so please look step by step. So let us first discuss the first type of functions, that is one functions. One functions are functions where each and every domain element has different images. Okay, so please write down. First of all, one function. It is also known as injective functions, is not it? So what is the definition? If every domain element has different images, okay, so if every domain elements has different image, then the function is known as one function. Then the function is one. Okay, so just consider the example, then it will be clear to us. Suppose these are two sets, and this is set A and this is set B. So give the name set A and set B. Here elements of set A are, suppose A1, A2, A3, and element of set B are B1, B2, B3. Okay. Now if A1 has F image B1, where F is a relation, suppose A1 has F image B1, A2 has F image B2, A3 has F image B3. Now look, here the relation f is a function, and in this case each and every domain element, that is a1, a2, a3 has different images. Is it? The image of a1 is b1 and b1 is not the image of any other domain element, is not it? So a1 has image b1, a2 has image b2, a3 has image b3. That is, the domain element a1, a2, a3 has different images. So this type of function is known as 1, 1 function. Consider another example, suppose like this. This is x and this is y. Elements of x are x1, x2, x3. Element of y are y1, y2, y3, y4 and so on. Okay. Now if x1 has phi image, that is if phi is the relation, that is x1 has phi image which is y1 suppose, and x2 has phi image which is y3, and x3 has phi image which is y4. So phi is the relation here which represents a function, because each and every domain element must have unique image in the codomain. And here the domain element x1 has only one image which is y1, x2 has also only one image which is y3, and these are different from y1, and x3 has also only one image which is y4, and all of the images, that is y1, y3, y4 are different. Is it? So this function phi is also 1, 1 function. Got it? So please write down here, f is 1, 1 function. Similarly, here phi is also 1, 1 function. Is it clear? Now we are discussing the second type of functions, that is many one function. Now write down please the heading, many one function. Okay. In the definitions of many one function, if at least two different domain element has same image. Okay. So what are many one function? Many one functions are functions where at least two different domain element has same image. Okay. So please write down, if at least two domain elements has same image, then the function is known as many one function, is known as, or function is many one. Okay. Clear? Just consider the mapping diagram again, then it will be clear to you. Suppose in this case there are two sets, name are capital S and capital K. Elements of set H are H1, H2, H3, and elements of set K are K1, K2, K3. So K1, K2, K3. Okay. So if H1 has, suppose G image, that is G is the relation, H1 has G image K1, that is K1 is equal to G of H1. H2 has G image K2 and H3 has also G image K2. So in this case obviously the relation G is a function. Why? Because each and every domain element, that is H1, H2, H3 has unique image in the codomain K. but the domain element H2 and H3 has same image K2. So that is why here the relation G represents many one function. Okay, so please write down domain element H2 and H3 has same image and the same image is K2. So that is why the function G is here many one function. So G is many one. Okay. So let us consider another example, then it will be more clear to us. Just if we consider this is capital M set and this is another set. Suppose this is capital N set. Okay, and the elements of M set are suppose M1, M2, M3 and M4 definitely, and elements of N are suppose N1 and N2. Now if the domain elements M1 and M2 has same image which is N1, that is M1 has image N1 and M2 has also image N1, and let the relation is here psi. Let the relation is psi, and the domain element M3 and M4 has also same image which is N2. So M3 and M4 has also same image which is N2. So in this case the relation psi is a function obviously, as all of the domain elements M1, M2, M3 has unique image in codomain N, but M1 and M2 has same image N1 and M3 and M4 has same image N2. So that is why this is a many one function. Okay, so write down psi is many one function. Many one function. Okay. So friends, now we are discussing the remaining two functions, that is onto functions and into functions. Okay, and these two type of functions, that is onto functions and into functions, are basically depends on the number of extra element present in the codomain. So here the codomain elements are important. If there are no extra element in the codomain, that is each and every codomain are image of any corresponding domain elements, then the function is known as onto function. And if at least one extra element present in the codomain, that is this extra element does not represent any image of any corresponding domain elements, then this type of functions are known as into functions. Okay, so first of all write number 3, that is onto function. So number 3 is onto function, and we know onto functions are also known as bisective function, is it? So what is the definition? If every codomain elements are image of corresponding domain elements, okay, that is every codomain elements are images of any corresponding domain elements. Okay, that is there are no extra element present in the codomain. That is there is no extra element present in the codomain. Okay, so if every codomain elements are image of any corresponding domain elements, that is there is no extra element present in the codomain element, okay, then the function is known as onto function. Then the function is onto function, or it is known as bisective function, is not it? Just consider the mapping diagram, then it will be clear to you. Suppose there are two sets. Name of this set are suppose A and B. Elements of set A are A1, A2, A3 and B1, B2, B3. The elements of set B. Now if A1 is related with B1 by the relation F, that is B1 is the F image of A1, A2 has image B2 and A3 has image B3. Now obviously here the relation F is a function, as each and every domain element A1, A2, A3 has image and unique image in set B. And look here, there are no element in set B which are not image of domain element. Okay, so obviously this type of function now it is known as onto function. So write down F is onto function here. Okay, now consider another example. Suppose so this is a set and another set is suppose this. Okay, so give the name of this sets suppose capital X and capital Y. Now declaring a relation psi and elements of X are considering as X1, X2, X3, X4 and elements of Y are declaring as Y1, Y2, Y3. Okay, now Y1 is the psi image of X1. So here we declare psi is the relation, okay, as well as function also. And X2 has psi image Y2, X3 has psi image Y3 and X4 has also psi image Y3. Now look, psi is obviously a function, as each and every domain elements X1, X2, X3, X4 has unique image in set Y. And there is no extra element in this codomain Y which is not image of any corresponding domain elements, is not it? So obviously this function is also onto function. Okay, so please write down here psi is also onto function. Okay, so in this way we can declare the onto functions, that is bisective functions. Now we are discussing the into function. So please look, what are into functions? So friends, now we are discussing the fourth type of function, that is into functions. Okay, so please write into function. That is non-bisective function, because onto functions are known as bisective functions. So these are non-onto, that is into. And into functions are functions where at least one extra element present in the codomain which does not represents image of any domain element. Okay, so please write down the statement of into functions, then we will discuss through mapping diagram. Okay, so into functions are functions where at least one codomain element does not represent image of any domain element, does not represent image of any domain element. Okay, just consider the diagram, mapping diagram, then it will be clear to you. So, considering these are two sets, give the name of these two sets are suppose set A and set B. Okay, elements of set are suppose A1, A2 and A3, and elements of set B are B1, B2, B3 and B4. Okay, now if A1 has F image B1, so F is the relation as well as function, A2 has F image B2 and A3 has F image B3, then there is an extra element in the codomain which is B4 which does not represent image of any domain element. So here the function F represents into function. Okay, so please write down F is into function. Just considering another diagram, mapping diagram, then it will be more clear to you. Suppose this is one of the set and another set is this. Okay, and name of this set is suppose capital X and capital Y, and images of set X are X1, X2, X3. Okay, and images of set Y are Y1, Y2, Y3, Y4. Okay, now let us declare a relation or as well as function that is psi between these two sets. That is, Y1 is the psi image of X1. Okay. Similarly, Y1 also psi image of X2. Let Y2 is the psi image of X3. So obviously here the psi is a function, and in this function at the codomain Y3 and Y4 are two extra elements which does not represent any image of domain elements, is not it? So that is why this function psi is also into function. So please write down psi is here also into function. Okay, so I think it is clear to us now, that is about the types of functions, one functions, many functions, onto functions and into functions. Is it clear? Now we will discuss about the number of functions from A to B, where A is the domain element and B is the codomain element. That is, here we will discuss the number of onto functions, the number of into functions, the number of one functions, the number of many functions, or total number of functions from A to B. So please look how we can calculate.